Students, today I am going to explain horizontal projectile motion and some applications based on horizontal projectile motion and parallelogram law of addition of vectors. So first I am discussing now horizontal projectile motion. Horizontal projectile motion. First, see this diagram. Suppose a body is projecting horizontally with velocity u from certain height h. Then the velocity of projection along x direction remains constant, but velocity of the body along y direction until equal to 0, the body moving horizontal only. After that, the body moving along the parabolic path. So like this, we can draw in the diagram. So now the distance from this point A to B is called horizontal range, and just after time t second, I am drawing here velocity along x direction and y direction. So it is parallel to x direction and it is parallel to y direction. Already velocity along y direction 0. That's why I took here uy 0, vy is equal to, so v is equal to u plus at. From that equation we can calculate. And the resultant of this ux vy is v with this velocity v, finally the body reaching on ground level, and it makes an angle alpha with the ground level. So separate now I am calculating this velocity along x direction and velocity along y direction. So but clearly from diagram, the velocity of a horizontal projectile body along x direction remains constant. Then acceleration along x direction is equal to 0. Similarly, in case of oblique projectile motion, in that oblique projectile motion also, there is no acceleration along x direction. So, but along y direction, in this horizontal projectile motion, velocity changing, that's why acceleration along y direction is equal to plus g we can take, because body moving downward direction. Now, u from v is equal to u plus at equation. So velocity along x direction is equal to u, but what I told, acceleration along x direction 0 into time 0. So therefore velocity along x direction is equal to u, and velocity along y direction. So vy is equal to, but u 0 along y direction plus body moving downward direction, then a is equal to plus g into time taken t. Then the velocity of the body along y direction is equal to g into t. Next, resultant velocity of these two, and we know angle between velocity along x direction and velocity along y direction is equal to 90. Then I am taking here theta is equal to 90 degree. So from resultant magnitude of parallelogram law equation, the resultant velocity of these two, v is equal to vx square plus vy square plus 2vx vy cos theta, but theta here 90 degrees. And if substituting vx value, vy value in this equation, that velocity v is equal to vx is u, then it is u square plus velocity along y direction, we got g into t whole square under root. This is the resultant velocity of vx and vy. With this velocity, finally, the body reaches to the ground level. So next one, in this same horizontal projectile motion, how much time taken by the projectile body to reach the ground level from top of the tower? So from s is equal to ut plus half at square equation, S is equal to ut plus half into at square. So from at what height the body is projecting horizontally from height h. So therefore here in place of S is equal to I am taking h is equal to velocity along y direction 0, 0 into t 0 plus half into so a into this time I am taking time of descent because time taken by the horizontal projectile body from top of tower to the ground level is I am taking time of descent. So therefore from this one, this time of descent square is equal to so 2 into h by a is equal to plus c. Then time of descent is equal to it is 2h divided by g under root. This is the time of descent. It means time taken by the horizontal projectile body from top of tower to the ground level. It means till point B. Next, so horizontal range. So horizontal distance or range in horizontal projectile motion. That range r is equal to range denoted by r. It is that range r is equal to it is a horizontal distance which is equal to distance from point A to point B. Then range r is equal to horizontal velocity into time taken to reach the ground level. So already we calculated this value time of descent. Then range of projectile r is equal to u into time of descent value under root 2h by g. So under root 2h divided by g. This is the range of the projectile. Next one, so the path of the horizontal projected body, we can prove it is a parabolic path like oblique projectile motion. So in oblique projectile motion also we got same thing. It is a parabolic path. What is that equation representing there? Already explained in before videos. Y is equal to ax minus bx square. Like this horizontal projectile motion also I am proving this is the parabolic motion. So parabolic path. Okay, see first here I am taking displacement of the body along x direction and y direction separately. First displacement of the body along x direction. Displacement along x direction. So displacement from S is equal to ut plus half at square equation. S is equal to ut plus half into at square. S is equal to h is equal to so u velocity u only along x direction, time taken t. But acceleration a is equal to 0, then half into 0 into t square. So 0 into something 0, then height h is equal to u into t. So therefore from this time t is equal to so h by u. H divided by u. This is equation 1. Similarly, displacement of body along y direction. Displacement of body along y direction. Same equation I am using here also. S is equal to ut plus half into at square. But displacement S is here y is equal to, but that velocity along y direction 0 plus half into this a is equal to g and t square. Therefore, y is equal to half into g. This is equation 2. But in equation 1, we can change it is here displacement s is equal to we can take x because here distance traveled by the body along x direction is equal to h. So So therefore, time t is equal to, in place of h, just I am substituting here x divided by u. So this is I am taking equation 1. Now equation 1, substituting in equation 2 in place of time t. So equation 1, substituting in equation 2. See then what happened? Y is equal to half into g. In place of t, I am substituting x by u whole square. So therefore, this is a displacement along y is equal to, so g by 2 into, after squaring this one, x square divided by u square. So except x square remaining right side, g by 2 u square constants, I am separating these constant values. Then y is equal to, so g by 2 into u square into x square. So therefore, this constant value I am taking some k into x square, where k is equal to, g by 2 u square. So we know y is equal to some constant into x square. This is the parabol equation. So from this equation, we can say the horizontal projectile motion path or trajectory is a parabola. Next, some applications you can solve based on this diagram. Some applications I am writing here. First one, so same body projecting like this. See, this is one staircase. This type of question is important for competitive level. So one ball is thrown from the one top of the step with velocity u. So take here each step height is a, I am taking, width of each step is b. Suppose here n steps are there. So, and for understanding purpose, I am drawing here one line like this, and this is connecting horizontal. Suppose this is the nth step. Then we want to find here a maximum height. At what height the body projecting with the initial velocity u, it is h value, and range of the projectile. Already we discussed about range of projectile and time of descent, time taken by the body from top of the tower to the ground. Here, top of tower nothing but h. So first one, so we know this equation, time of descent t suffix d is equal to, so 2 into h by z, we know this equation. But each step height we know here a. But how many steps we took here? Small n. Small n is the number of steps. So therefore, for total height of the steps is equal to, we should multiply h value with n. Suppose 2 steps are there, 2 into n. 3 steps are there, 3 into n. Like that. For n steps, what happened this equation? N into h divided by g. So therefore, time of descent is equal to, so 2 into n into h, n into, so a I am taking here, n into a divided by g under root. This is the time of descent. So here what I substituted, the height h is equal to each step height a into how many steps we have here n. That's why h is equal to n into a. Similarly, range of the body, we know range r is equal to, what is formula we know? U into 2h by g under root. So r is equal to the velocity u into horizontal distance it is. Horizontal distance r is equal to u into, so 2 into h by z. Just to substitute in place of this h value again, this one, which value? So 2 into, so n into a divided by h under root. This is the height. So if you want only height of the tower, h is equal to number of steps into height of each step. Next, based on parallelogram also, one or two applications I am explaining here. The second one now, second application. So we know magnitude of resultant equation. Which equation we know magnitude of resultant? That is r bar is equal to, so p bar square plus q bar square plus 2p bar q bar, cos theta we know. So suppose here, if the two vectors equal in magnitude, so p bar is equal to q bar, p bar is equal to q bar, just magnitudes I am equating here. Then if substituting these two values in this above equation, that range r bar is equal to, so this is p square plus, just I am converting in terms of p because both are equal, then p square plus p square plus 2 into p, q value is p, and cos theta under root, which is equal to, so p square plus p square 2p square plus, so 2p square cos theta it is, under root it is, so which is equal to, so which one we can take common here, 2p square common. If we are taking 2p square common, then it is 1 plus cos theta under root. So which is equal to 2 into p square, but I am applying here cos 2 theta formula. So 2 cos square, we know cos 2 theta formula. Cos 2 theta is equal to 2 cos square theta minus 1. This formula I am substituting here, 1 plus, but here cos theta is there. Then what I am taking here, 2 cos square theta by 2 minus 1 under root. So plus 1 minus 1 cancel. Then if multiplying this one, 2 2 is a 4, 4p square cos square theta divided by 2 under root. So therefore, magnitude of resultant r bar is equal to, if you are taking outside root these values, then this is 2p cos theta by 2. This is the final equation. And one more application based on the same parallelogram law. The third one, if the resultant of two vectors of p bar and q bar is normal to the one of the vector, then we should find what is the angle between the two vectors. See, I am drawing this diagram. So suppose I am taking r is the resultant of two vectors p bar and q bar. It is the resultant, and this is p, and this is one more vector q. So this is the resultant r bar, and this is one vector p bar, and this is another vector q bar. So we know here angle between these two 90 means this is alpha. Alpha is the angle made by resultant of p bar q bar with the direction of p. So here alpha is equal to 90. But which angle is theta? Theta is the angle between two vectors, p bar and q bar. This is theta. Now we want to find theta value here. So then see what I am doing here first. Alpha formula I am using. So which formula we know alpha? Tan alpha is equal to q sin theta by p plus q cos theta. But in place of alpha, I am substituting 90 degree here. Then tan nothing but we know sin by cos. Then sin 90 divided by cos 90 is equal to, so q bar sin theta divided by p bar plus q bar cos theta. So sin 90 value 1, cos 90 0. So g1 divided sin 90 1, cos 90 0. 1 by 0 is equal to q bar sin theta divided by, it is p bar plus q bar cos theta. So just I am equating in denominator values. 0 is equal to p bar plus q bar cos theta. So then q bar cos theta is equal to minus of p bar, and cos theta is equal to minus p bar divided by q bar. So by using this formula, we can calculate angle between two vectors p bar and q bar. This is the important equation for competitive level.